Good evening, dear students. Let us start our class. Today we are going to discuss system of linear equations. Before I start, please confirm couple of you that you are able to hear my voice very clearly and also able to view the screen properly.
Yes, sir.
Okay, thank you very much. A couple of students confirmation is sufficient. Everyone no need to tell. Okay. This is a very important topic and you will see that by means of both matrices and determinants, how we can solve a system of linear equations. Before that, dear students, let us understand what is system of linear equations. Okay, so to explain this thing, first let me take an example. Once I take an example and explain things, it will be very easy to understand. After that, we will go to the theory, and once we go to the theory after explaining then one example, you will find that things are pretty quite understandable. So let me consider an equation something like this: 3x minus 2y plus 3z, 3x minus 2y plus 3z is equal to 8. Second one is that 2x plus y minus z equal to 1. 2x plus y minus z equal to 1. And third one is 4x minus 3y plus 2z equal to 4. 4x minus 3y plus 2z equal to 4. If you look into this, these three equations, this is called system of linear equations. Why it is linear? Because you see, dear students, the power of x, y, and z, the unknowns, are 1. That is why it is linear. And why it is system? Because there are three equations. These three equations constitute a system. Dear students, if I give you one equation or two equations with three unknowns, you will see that you can find many solutions. The point is that in general principle in solving equations, the number of equations should be the number of unknowns so that we can find the solution. Solution means what? Solution means the values of x, y, and z which is satisfied by all the three equations what you see. That is why it is called a system of linear equations. So in today's session, we are going to learn how to solve this system of linear equations. And we will take help from matrices and determinants to solve these linear equations. And dear students, what we can write, if you see this equation, we can write this equation in a matrix format also. How we can write in a matrix format? It is something like this. You see, I can write 3 minus 2, 3, 2, 1, minus 1, 4, minus 3, 2. Then we write here that x, y, z, and then we write here it as 8, 1, 4. Now, if we apply the concept of matrix multiplication, you will see whatever the system of linear equations you are seeing here, that is actually represented by this matrix format. Isn't it, dear students? Now, this matrix can be, symbolically represented something like this. This implies A into X is equal to B. where the matrix A is denoted by this 3 by 3 matrix. Matrix X is denoted by this column matrix XYZ, and the matrix B is denoted by this column matrix 814. Now, dear students, there are specific names for these matrices in context to the discussion of system of linear equations. The matrix A is known as the coefficient matrix. What I said, dear students, it is known as the coefficient matrix. Let me write it down. So this matrix is, this matrix A is known as the coefficient matrix. Why it is called coefficient matrix? Because it consists of all the coefficients of the unknowns x, y, z. Think about, in the first equation, it is 3x minus 2y plus 3z equal to 8. What are the coefficients of x, y, and z in this first equation? It is 3, minus 2, and 3. 3, minus 2, and 3. And that's what we have written it here. 3, minus 2, and 3. In the similar manner, in the other two rows, we have written the coefficients of the x, y, z of the other two equations. Hence, the matrix A is known as the coefficient matrix. The matrix X is known as the, variable matrix. Why it is called a variable matrix? Because it contains the variable x, y, z. Variable matrix. Why it is called a variable matrix? Because it contains the variable x, y, z. And what is our target, dear students? Our target is to find the value of x, y, z. And what is the matrix B is called, dear students? The matrix B is known as the constant matrix. That matrix B is known as the constant matrix. So, dear students, what we see is that the system of linear equations is now very clearly represented as a product of coefficient matrix and variable matrix, and that is equal to the constant matrix. Why it is called a constant matrix B? Because it consists of all the constants. 814 is the right hand side of these three equations. Now, in a very simple term, how to find a solution to this equation? Simple term I am telling, because there are some cases, sub cases that we will all discuss. But in simple term, to understand why we are learning that solution to the system of linear equations here during the learning of matrices and determinants. Think about, dear students, this equation Ax equal to B. From this equation, what we can write, dear students? From this equation, let's assume the matrix A is invertible. Let's assume. Then what we can do? We can, pre-multiply, both sides with A inverse. We are assuming that A inverse exists. Simple term. I'm again repeating, dear students. It is simple term. We'll come to all the different cases, corner cases, conditions later. Fine, because we are multiplying both. Pre-multiplying means A inverse is actually in the beginning, in the left hand side of both the sides. And we know, dear students, matrix multiplication is associative. So what we can write? A inverse Ax, we can write is that A inverse A into X, that is equal to A inverse B. Now, dear students, tell me, what is A inverse into A? A inverse into A is nothing but the identity matrix. So we can write it as an identity matrix. Ix is equal to A inverse of B. So I into X means what? X. That implies X is equal to A inverse of B. And this is what the solution. Because once you get the A inverse, and if you multiply that matrix A inverse with the matrix B, you will get a column matrix. that column matrix is equal to the matrix X, and we will find the value of X, Y, Z. So in this way, we can find the solution using the matrix method. Later, we will discuss the same system of equations we can solve using the determinants method. We will see this thing, but this is the way we actually find the solution. But now, let us generalize this case, dear students. If I generalize this case, and if I write in a different color, how I can represent this system of equations. What I given to you so far is actually an example. Now I am writing these equations in a generic form, a 3 by 3, because most of the questions in your examination will come with a 3 unknowns and 3 equations. So what it will be? A11 into x1 plus a12 into x2 plus a13 into x3 is equal to b1. So here, instead of x, y, z, the unknowns, what we took for the in an example, I am taking the unknowns are x1, x2, x3. Then next equation will be a21 x1 plus a22 x2 plus a23 x3 is equal to b2. Then we come a31 x1 plus a32 x2 plus a33 x3 is equal to b3. So this is the generic representation of the example what I explained few minutes back. Now, dear students, if you look into this system of equations, now if we get that bi is not equal to 0 for each of I is equal to 1, 2, 3, then we call this system of linear equations as non-homogeneous equation. So that means what? There are few terminologies I am going to discuss, dear students. If bi is not equal to 0 for each I is equal to 1, 2, 3, then we called the system of linear equations as non-homogeneous linear equations. Okay, so if we name these equations as system of linear equations 1, so I is called non-homogeneous linear equations. Non-homogeneous linear equations. Now in the second case, if we get bi equal to 0, that means right hand side, right hand side everything we get 0. So what is an example of a non-homogeneous equation? Is an example is this, what you see. Because 8, 1, 4, they are not 0. That is called a non-homogeneous linear equation. Now, if we get bi is equal to 0 for all I, okay, for all I is equal to 1, 2, 3, then this above equation is called homogeneous linear equations. Homogeneous linear equations. These are the different terminologies, dear students. So the example what you see, dear students, in the right hand side, when it will become an homogeneous linear equations, it will be something like this. Then it will be homogeneous linear equations if we write 3x minus 2y plus 3z is equal to 8, sorry, equal to 0. Then 2x plus y minus z is equal to 0 and 4x minus 3y plus 2z is equal to 0. When we write like this, then we call it is a homogeneous linear equations because the constant matrix becomes a null matrix. Now, what we are going to solve, as I said in the beginning, dear students, we are going to find the value of x1, x2, x3. If at least one set of values of x1, x2, x3 is found satisfying all the above set of three linear equations in equation 1, then we say what? Then we say that the above system of linear equations are called consistent. Consistent means what? If we find at least one set of values of x1, x2, x3, so that all these equations, what you see, dear students, here are satisfied, then we can say the system of linear equations are consistent. Now, as I said, at least one, that means what? We can have many values, more than one, then also it is consistent. Okay. So, what I'm saying, dear students, is that I'm writing it here that if at least one set of values of, I'm just writing in details, if at least one set of values of x1, x2, x3 can be found satisfying all the above set of linear equations 1, satisfying all the above system of all the above system of linear equations 1, then the above system of linear equations are known as consistent. Then above system of linear equations 1 are known as consistent, consistent. So I'm writing it uppercase so that you understand that it's important. Now it may possible that we get more than one set of values of x1, x2, x3, then also it is consistent. Okay, but at least one if we get, then only it is consistent. If we get more than one, then also it is consistent. But sometimes it is possible, dear students, that we are not able to find any values of these unknowns. Okay, that means no solution exists. Then we say the system of linear equations are inconsistent. That means what, dear students? If no such set is possible, so if we can write in this way, that if it is done, if no such set is possible, no such set is possible, then the above system of linear equations 1, then the above system of linear equations 1, let me write properly, are known as inconsistent. Okay. So dear students, by this time you understood that what is known as a consistent system of linear equation and what is known as a inconsistent set of linear equations, correct? Now, what is our target? Our target is to find the solution to this system of linear equations, correct? Now, how we are going to find it out, that we are going to learn. Okay, dear students, so how to find that, system of linear equations, how to steps to find the, the system of linear equations, steps to find that solution to the system of linear equations. So then, dear students, what we get from this system of linear equations 1, if you see from this system of linear equations 1, we can express something like this. Okay, if we write this thing in the same manner, the example what I gave now, dear students, that the same system of linear equations 1, we can express something like this. That system of linear equations 1 can be written as A11, A12, A13, A21, A22, A23, A31, A32, A33, and then that is the whatever we wrote is known as the coefficient matrix. Then we are writing the variable matrix x1, x2, x3, and that is equal to the constant matrix b1, b2, b3. So as we know, this matrices are named as ax equal to b, correct na? Where A is the matrix representing the coefficient matrix, X is the variable matrix, and B is the constant matrix. Now, apart from these three matrices, so I'm writing it down also, that this is known as the, I'm writing once more, variable matrix. Variable matrix. And you see, dear students, this is known as the, I'm so sorry, I made a mistake. A is known as the coefficient matrix. Coefficient matrix. The matrix X is known as the variable matrix, and the matrix B is known as the constant matrix. Now, dear students, we are introducing another matrix, and that matrix we name as augmented matrix. And what is that augmented matrix? That is, we denote it by AB. And what kind of matrix it is? It contains that all the elements of the coefficient matrix, that is, we can write it that A11, A12, A13, then A21, A22, A23, then A31, A32, A33. Then we add one more column that is called B1, B2, B3, which is the element of, which are the elements of the constant matrix. Correct, dear students? So you see the coefficient matrix is a square matrix of order 3, but augmented matrix is not a square matrix. It is a matrix of order 3 by 4. It has 3 rows and 4 columns. Now, this matrix, as I said, it is known as the augmented matrix. Okay, dear students, it is known as the augmented matrix. So let me, this is known as augmented matrix. So dear students, so far we understood there are 4 matrices: coefficient matrix, variable matrix, constant matrix, and augmented matrix. Now we are going to discuss about the consistency of the system of linear equations. How? And for that, dear students, we need to take assistance of the rank of a matrix. Dear students, if you recall, in the last class we discussed about how to find the rank of a matrix. And during that class, I told you that one importance of finding the rank of a matrix is to finding the system of linear equations. Those who wants to revise that particular class, you can look into the YouTube videos. It is available. And also you can look into the online platform of konarclasses.com to get it. Now, dear students, how we can find the steps to find the consistency of a linear equations, that we are going to discuss now. So here are the steps which I am taking it from my class note, my study material, and show it to you. And later also I'll share all the study materials with you. This is a very important piece of information I am just placing in front of you. So we need to find the rank of 2 matrices. We need to find the rank of the augmented matrix, and we need to find the rank of the coefficient matrix. And dear students, rank is a pure number. It is a natural number. Okay. Now, the step 1 is that if the rank of the coefficient augmented matrix is equal to the rank of the coefficient matrix, that means what? If the rank of AB stands for that augmented matrix and A stands for the coefficient matrix, if rank of AB is equal to rank of A, then the above system of linear equations are inconsistent and have no solution. So I repeat, dear students, if the rank of the augmented matrix is not equal to the rank of the coefficient matrix, you can just simply say that the system of linear equations are inconsistent and have no solution. Now, if the rank of the augmented matrix is equal to the rank of the coefficient matrix, that is rank of AB is equal to rank of A, and that is equal to n, the number of unknowns. In this case, it is 3. How many unknowns are there in that equation what I took? There are 3, x1, x2, x3. And in generic way, I mention it is 3n, but it is actually 3 in context to our discussion. If rank of AB is equal to rank of A is equal to n, the number of unknowns, then the above system of linear equations are consistent and have unique solution. So here I am writing that here the n is equal to 3. Correct? So if rank of the augmented matrix is equal to the rank of the coefficient matrix is equal to the number of unknowns, because rank of a matrix is a natural number, dear students. That means, suppose in this case, this particular case, if we find the rank of the augmented matrix equal to 3 and rank of the coefficient matrix is equal to 3, then what we see, there are 3 unknowns. So rank of augmented matrix is equal to rank of the coefficient matrix is equal to the number of unknowns. And what we can conclude? We can conclude, yes, the system of linear equations is consistent and have unique solution. What is meant by unique solution, dear students? That means you can get only a single set of values of x1, x2, x3. That is why it is called unique solution. Okay. Now, if we see the rank of that augmented matrix is equal to the rank of the coefficient matrix, but it is not equal to the number of unknowns, then we can say the system of linear equations are consistent but are having infinite number of solutions. So what is meant by consistent? Consistent means it is having a solution. Now if the solution is unique, that is called consistent and unique solution. And if number of solutions are more than one, okay, infinite in this case, that is known as, that is also consistent but having infinite number of solutions. Inconsistency is mentioned only when there is no solution. So these are the three cases, dear students, in context to the discussion what we are having. So just by looking into the equation, we can quickly form the three matrices: coefficient matrix, variable matrix, constant matrix, and augmented matrix. After that, we can find the rank of that augmented matrix and rank of the coefficient matrix, but that cannot be done quickly. Finding rank will take some time, but not a big amount of time. Okay, and I repeat, how to find the rank of a matrix. For that, you need to refer to my other video lectures where I discussed in details about how to find the rank of a matrix, dear students. Then if we see the rank of that augmented matrix is equal to the rank of the coefficient matrix and equal to the number of unknowns, then we can say the system of linear equations are consistent and having unique solution. Unique means only a set, only one value of x1, one value of x2, one value of x3. If we see the rank of that augmented matrix is equal to the rank of the coefficient matrix, but that is not equal to the number of unknowns. Actually, it is not equal to number of unknowns means it should be less than the number of unknowns. Then we say that system of linear equations are consistent but having infinite number of solutions. That means we can have infinite number of values of x1, infinite number of values of x2, infinite number of values of x3 to satisfy the given set of equations, linear equations. Now if we find a rank of the augmented matrix is not equal to the rank of the coefficient matrix, very simple to say, the system of linear equations are inconsistent and having no solution. Now, once we found that consistency and inconsistency of that system of linear equations, then finding the solution is very easy. I explained by means of that example, dear students. If you see that ax equal to b, sorry, and from there you can find the solution by having the inverse of that matrix. Correct, dear students? So how to find the solution to the system of linear equations? That is also I already explained, but I'm just informing and just showing you that how we can achieve it by means of this statement. So I'm just writing the generic statement from my study material, and here it is. Solution to a system of linear equations by matrix method. So what is that method, dear students? Here it is. We see that we can express the above system of linear equations by means of this following matrix, that is ax equal to b, where a is the coefficient matrix, x is the variable matrix, and b is the constant matrix. By pre-multiplying both sides of the equation by A inverse, what we get, dear students? We get A inverse of Ax is equal to A inverse B. Assuming A inverse exists, that means A is a non-singular matrix. That means A inverse exists. Now, we know the matrix multiplication is associative. So A inverse of Ax, that means A inverse of A into X. So this is correct. Now, what is A inverse into A? We know that if we multiply a matrix, square matrix with its own inverse, then we get an identity matrix. That is why we wrote Ix equal to A inverse B. And what is I? I is nothing but the identity matrix. And we know, dear students, that if we multiply an identity matrix with any other matrix of the same order, we get the same matrix. So I into X is equal to X, and we get A inverse B, and this is the required solution. Correct, dear students? Now, let's see how we can find the solution. Okay, so let us find it out. So let us take an example to find that how we can solve the system of linear equations using matrix method. And for that, dear students, I am taking assistance of this, example. At any point of time, dear students, as I said, any issue, anything you didn't understand, never hesitate. Okay, ask me, I will clarify your doubts. So what we are going to discuss is that we are going to find the solution to this system of equations by matrix method. How we are going to solve that we'll see. Now, dear students, from this system of linear equations, what we can write? We can write this is equal to ax equal to b. Okay, where a, which is the coefficient matrix, is nothing but 3 minus 2, 3, 2, 1 minus 1, 4 minus 3, 2. That is the coefficient matrix A. And what is x? X is the variable matrix, dear students. That is x, y, z. And what is the b? B is the constant matrix, dear students. That is 8, 1, and 4. Correct, no, dear students? B. Now, dear students, what I'm going to find is that we'll first find that rank of that augmented matrix and rank of the coefficient matrix. Okay, and you will find it out that they are equal to 3. Now, as they are equal to 3, that you can find it out, because here my sole purpose is to discuss on the solution to the system of linear equations. Sure. And what you find is that AB, that is the augmented matrix. Augmented matrix will be something like this: 3 minus 2, 3. First you write that coefficient matrix: 2, 1 minus 1, and then 4 minus 3, 2. And after that, add one more column containing the elements of the constant matrix, that is 8, 1, 4. And you find the rank of AB and rank of A. And if you find, dear students, you can do it, because I want to discuss more on the system of linear equations. So rank of AB should be equal to rank of A. Okay, and that is equal to 3. So what it tells? It tells that the system of linear equations are consistent and having unique solution. Because it is 3, 3 is the number of unknowns, so this implies the system of equations, the system of given linear equations are having unique solution. Okay, I can tell you more elaborately. Are consistent. We can like consistent. Solution exists means consistent. Consistent and having unique solution. Correct, my dear students? Now we are going to find the solutions to this one. So as we see, let me use a different color. Ax equal to b. So from here, what we can write, dear students? So we can find that A inverse. So A inverse of Ax is equal to A inverse of, just a minute, let me write properly. So what you can write is that A inverse of Ax is equal to A inverse of B. Obviously, A inverse exists because rank of A is equal to 3, na? So this implies A inverse of A into X is equal to A inverse of B. Now A inverse of A is I into X is equal to A inverse into B. So from here, what we can say, dear students? From here we can say that X is equal to A inverse into B. Now, I am not discussing about, I'm going to the each and every step to find the inverse of that matrix. That you can follow my other video lectures and find it out. because I know that you know how to find an inverse of a matrix. So then what we are going to get, dear students, what is X? X is X, Y, Z. And you know, dear students, if you find the inverse of that matrix, you will find the inverse of this matrix something like this. Is that minus 1 by 17. I'm just writing it out. After the class, you can try and you will get this value. If you do not get, do let me know. Minus 1, minus 5, minus 1. Minus 1, minus 5, minus 1. Then minus 8, minus 6, 9. Minus 8, minus 6, 9. And then minus 10, 1, 7. Minus 10, 1, 7. And then the constant matrix, that is 8, 1, 4. 8, 1, 4. And you know, dear students, if you multiply all these two matrices in the right hand side and do further simplification, what you are going to get? You are going to get something like this, that X, Y, Z, that is equal to, you will get 1, 2, 3. And now we can apply the concepts of equality of two matrices. When two matrices are equal, the corresponding elements are equal, dear students. So what we can say? We can say X is equal to 1, Y is equal to 2, and Z is equal to 3. This is the solution to the given system of linear equations, dear students. Correct? I hope all of you got it very clearly, dear students. And now what I'm going to discuss, dear students, is that solution to a system of linear equations by determinant method. So far what you have learned? That we have learned using the matrix method. Now we are going to learn the solution to a system of linear equations using determinant method. Let's see how we can find it out, dear students. So, solution to a system of linear equations using determinant method. So I'm just keeping it from my from the study material, dear students. So how to find it out, and we'll discuss in details. So here, dear students, what we need to do is that let me just a minute. Let me give a proper heading and then let me explain you. Solution to a system of linear equations by determinant method. Now, let us consider the following set of simultaneous linear equations. By the way, this system of linear equations are also known as simultaneous linear equations. Okay, why it is called simultaneous, dear students? It is known as simultaneous because all the unknowns are also can change at the same time. Okay, that is why simultaneous, because all the what happened? All the three unknowns, all the three equations can execute at the same time. When few things can execute at the same time, we call it as a simultaneous. Okay, so now let me first place the point in front of you. Let us consider the following set of simultaneous linear equations, and we are going to find the solution to this system of linear equations using a method, and that method is known as Cramer's rule. Cramer's rule is a simple method to find the solution to the system of linear equation using the properties of determinants. And we are going to see how we can leverage these properties of determinants to find the system, solution to the system of linear equations using determinants. So Cramer's rule is the what we are going to use is that Cramer's rule. And what is this rule? Very simple. Pretty simple actually. This Cramer's rule is pretty simple. Let me use a red color. Now, from these three, as you see this system of linear equations, there are three equations, dear students. Now, from these three equations, we are going to form four determinants. What are the four determinants? These are the four determinants. We are going to find it out. Okay. Just have a look into the four determinants, and then let me first show it to you. Then after that, I'll explain that how we can form this determinant. What are the four determinants? Delta, delta 1, delta 2, delta 3. What is delta? Delta is nothing but the determinant corresponding to the coefficient matrix. That means if you see the delta, it contains A1, B1, C1, A2, B2, C2, A3, B3, C3. What is all this A1, B1, C1? A1, B1, C1 is nothing but the coefficient of x, y, z of the first equation. What is A2, B2, C2? Is the coefficient of x, y, z in the second equation. What is A3, B3, C3? It is the coefficient of x, y, z of the third equation. So that's my delta. From the delta, we are forming three more determinants, delta 1, delta 2, delta 3. How? The delta 1 should be, the first column of delta should be replaced by K1, K2, K3. K1, K2, K3, it is the constant matrix if you express in the form of a matrix. So K1, K2, K3, we will replace A1, A2, A3. And that's why we form delta 1 from delta. Delta 2 is also formed for delta by replacing the second column by K1, K2, K3. That means second column of the determinant delta should be replaced by K1, K2, K3 to get delta 2. And that's what we get. And in the similar manner, dear students, delta 3 is the determinant obtained from the determinant delta by replacing the third column of the determinant delta by K1, K2, K3. Fine. So now we form this four determinants, delta, delta 1, delta 2, and delta 3. After that, dear students, it is very simple to form the solution. If delta is not equal to 0, then what we can say, that solution to the system of linear equations is given below. If delta is not equal to 0. So how we can say this thing? We can write in this manner. Okay. How we are going to find it out? That x is equal to delta 1 by delta. By the way, equation 2 means this is known as the equation 2. This is equation 2. This is equation 2. I didn't write it earlier. This is equation 2. Okay. This, whatever you see the system of linear equations, this is equation 2. Now, if delta is not equal to 0, then we can find the solution to the given simultaneous linear equations as x is equal to delta 1 by delta, y is equal to delta 2 by delta, and z is equal to delta 3 by delta. As simple as that. This is the way we can find the solution to the system of linear equations using the determinant method that is known as Cramer's rule. Now, dear students, you may have a question that, sir, using determinant method, can't we determine whether the system of linear equations are consistent or not? Or whether they have unique solution or not? Yes, of course, we can. So how? By means of Cramer's rule also, we can find the consistency of the above system of linear equations to what you see that equation 2 by means of this way. What is that? Let me first, place the note, and then let me explain you. So by means of Cramer's rule also, we can find the consistency of the above system of linear equations too in the following manner. If delta, that is the determinant corresponding to the coefficient matrix, is not equal to 0, then we can say the system of linear equations are consistent and has unique solution. Okay, dear students? If we see the delta is not equal to 0, then the system of linear equation, delta you understood, no? These are delta. Delta is not equal to 0. Then the system of linear equations are consistent and having unique solution. Second case, if delta is equal to 0 and at least one of the determinant of delta 1, delta 2, delta 3 be non-zero, then the system of linear equations has no solutions and are inconsistent. And third case, if delta equal to 0 and delta 1 is also 0, delta 2 is also 0, delta 3 is also 0, then the system of linear equations having infinite number of solutions and obviously consistent. As I said several times today, consistent means having solution, either unique or infinite. Inconsistent means no solution at all. So dear students, what you observe, with the help of determinant also, not only we can find the solution to a system of linear equations using Cramer's rule, also we can judge whether the system of linear equations are consistent or not. And not only that, if it is consistent, whether it is having unique solution or not, as I explained in the last few minutes. Then you may be thinking, sir, what to do? You taught matrix method, you taught determinants method, then what do you want to do? So we see that to find whether a system of linear equations are consistent or non-consistent, we can follow any of the following methods. First method is by comparing the rank of the coefficient matrix and augmented matrix with respect to the number of unknowns, or by calculating the values of the different determinants as mentioned in the Cramer's rule. Please note that in the case when you are using the Cramer's rule, the coefficient matrix has to be a square matrix, obviously. Okay, means the number of equations must be equal to the number of unknowns, which may not be required for a, when you are finding the solution using, matrix method. That means it may possible that number of unknowns are not equal to the number of, equations. And these are the very generic case. I didn't discuss it because most practical case is the number of, equations and number of unknowns are same. Now there is a special case. So what we discuss here is that, so whatever I said, I just want to write in front of you, dear students, and here it is. So the statement what I am going to write, dear students, is something like this. So we see that to find whether a system of linear equations are consistent or not consistent, we can follow any of the following methods. What are the methods? By calculating and comparing the rank of the coefficient matrix and augmented matrix with respect to the number of unknowns, and by calculating the values of the different determinants as mentioned in the Cramer's rule. Please note that in this case, the coefficient matrix has to be a square matrix. I will come to this particular topic after some time, dear students, today itself. Means the number of unknowns has to be equal to the number of equations must be equal to the number of unknowns. Now, dear students, if you look into the first equation, that if you look into this particular equation, dear students, is that what you have done? K1, K2, K3. Now what will happen if K1, K2, K3 is 0? That means in other ways, what will happen if it is an homogeneous linear equations? Let's understand this case with respect to the determinant. Okay, dear students. So if we consider that K1 is equal to K2 is equal to K3 is equal to 0, then the above system of linear equations 2, means what I just showed you, can reduce it something like this. Correct or not? If you make K1, K2, K3 is equal to 0, then the above system of linear equations reduces something like this, as you see, dear students, in front of you. It will be something like this. Now, by means of Cramer's rule, we can find the consistency and some idea about the solution to the system of linear equations. Okay, we give that linear equations as number 3. If delta is not equal to 0, the system of linear equations has trivial solution x equal to 0, y equal to 0, z equal to 0 and are called consistent. Now why I introduce the word trivial? Trivial means which is by default possible. It is so simple. And you know, whenever you get this equation a1x plus b1y plus c1z equal to 0, a2x plus b2y plus c2z equal to 0, a3x plus b3y plus c3z equal to 0, where x, y, z are unknowns, one solution what comes to your mind is x equal to 0, y equal to 0, z equal to 0. Obvious, no? For that I no need to have any knowledge of matrix or determinants. Basic common sense. Because right hand side is 0. So if I apply x equal to 0, y equal to 0, z equal to 0, definitely it is going to be satisfied. As it is so simple, so easy, and it comes with a very basic things without having any extra information or extra knowledge. That is why the word we used is a trivial solution. So dear students, if delta is not equal to 0, then we say that the system of linear equations having a trivial solution, x equal to 0, y equal to 0, z equal to 0, and are called consistent. Why consistent? Because we got a solution set, no? But if delta equal to 0, first case we have done, but if delta equal to 0, the system of linear equations 3, that is a homogeneous system of linear equations, has non-trivial solutions. Means there exists solution apart from x equal to 0, y equal to 0, z equal to 0. X equal to 0, y equal to 0, z equal to 0, so obviously a solution. But apart from that also there exists another set of solutions, okay, if delta is equal to 0. So this is about the, how we find the solution to a system of linear equations using, Cramer's rule, that is called the determinant method. So we are almost done, dear students. But before that, I would like to tell you some generic statement. Okay, dear students. So I'd like to mention some generic statements so that you understand that how these solutions are actually being found. Okay, now generic statement is that which I didn't mention purposefully in the beginning, that what is a system of linear equation. Let us revisit once, because initially we should start with small examples, small prototype, so that you understand it very well. Now as our understanding is clear, now we can discuss what is a system of linear equations. Okay, this is a system of linear equations, so that I want to show it to you. Okay, and here you will find something more generic. Okay, so what it says, dear students, it says that let us consider the following system of m linear equations in n unknowns. Okay, m linear equations in n unknowns. That means number of equations are m. Okay, there are m number of equations. M number of equations, as you see, a11 x1, a21 x1, a31 x1, first term, and in that way m1 x1. And how many unknowns are there? x1, x2, x3 up to xn. So what we see, dear students, these are n number of unknowns, and this is the most generic way of representing a system of linear equations. Now if I revisit this statement, dear students, if bi is not equal to 0 for each of I equal to 1, 2, 3 up to m, we say the above system of linear equations as non-homogeneous linear equations. If bi is equal to 0, that is for all I, if bi is equal to 0 for all I 1, 2, 3 up to m, we say the above system of linear equations as homogeneous linear equations. If at least one set of values of x1, x2, x3 up to xn can be found, satisfying all the above system of linear equations 1, then the above system of linear equations 1 is known as consistent. If no such set is possible, then the above system of linear equations are known as inconsistent. I hope you got a very fair amount of idea, dear students. If in case any difficulty, please do let me know. And dear students, with this, I would like to conclude the class for today. But before I conclude, I always recommend, dear students, please visit www.honarclasses.com, enter your login, okay, click in login and enter your login and appear for DPP, okay, then PT, then UT, then MDT, and finally MT. DPP stands for what? As I said, dear students, DPP stands for, sorry, what I wrote, just a minute. So let me write once more. Please log on to honarclasses.com and appear for DPP, daily practice problems, then it is PT, practice test, then UT, unit test, then MDT, module test, and then finally MT, that is mock test. If someone, you can also, in addition, you can look for great quality video lectures. If someone of you do not have login, please do let me know, and I will help you to create your login, dear students. So for login creation, you can contact me here. Let me write it down. That email is contact@honarclasses.com, and also you can WhatsApp or call in the number 80950100670. So with this, dear students, I would like to conclude the class for today. Our next class is on Wednesday, and we will discuss a new topic then. With this note, I would like to conclude. Thank you very much. Take care.
Thank you, sir.
Thank you, sir.
Thank you. Thank you, Ishika.